All right, what about X and Z, the ones that were part of the local scope of the script? Should we be able to access them or not? We should be able to access them, right? Because it's an inner scope. And we know that the inner scope should be able to see what's outside. But in order to be able to see them when we are in the debug, we have to refer to them. Okay, so I'm just gonna try to print here. Let's take these. All right, I'm gonna stop inside. I'm gonna stop before the execution, or maybe I can just stop here because we know that we are stepping inside the function. Okay, now let's see. So you see there's a new type of closure that was introduced here. Before we try to access X and Z, we only saw the local scope of the function print and the global scope, right? Now we are trying to access something from the surrounding function. Okay, now we can treat the module as if it was a function. What is the outer scope? So an inner function can access the scope of the outer function through the closure scope. Okay, so if I open that, I will see that X and Z are here. All right. Okay. Now, because the module is creates a function, so it is part of the closure as well. So what if we have so just one note, we can only see the word closure if we are inside a function. So you see, this is the beginning and end of that function, and we are pausing inside that function, right? So the concept of a closure scope is only associated to a function, and it allows it access to the scope of its outer surrounding function. Okay? Now, what if we created an actual function? And now let's see if we created an actual function, what's going to happen? So we have an outer function called print, and then inner function called inner function. Okay, so that inner function would have its own local scope, right? So here we are stopped inside that inner function. So this inner function has its own local scope, and it can access the outer function through a closure, first level of a closure. And then the surrounding module is still accessible through the outer closure. So this is the closure that represents the module, and then there is the closure that represents the outer function, and then there's the local context or the local scope of the function that we are stopped inside. Okay, is this clear? Okay. So you see here we have, from here we can see 3 levels above. Okay. Now, what about the local or the block scope? Now, in JavaScript before 2015, the block scope didn't exist. So whenever we have curly brackets, that creates a block scope. In Java, whenever there is curly brackets, whether it's part of an if statement or for statement, that curly brackets, that block, creates a scope. In JavaScript, that concept didn't exist before 2015. It was introduced after 2015. Now, the old way of defining variables using the keyword var doesn't recognize that scope. So if you have an if statement that has a block, and then inside that block, you have a variable defined with the keyword var, this is not a local variable. This is not a block variable. That variable belongs to the outer scope, whatever that is. But if you define it with a const or let, that variable or constant would belong to the block, and it would not be accessible outside. Okay, and that's why var is problematic, and it's good to try to avoid it. It causes a lot of confusion. It behaves differently on the browser too. Now, if you are writing the code, it's good to try to avoid var. But when you're working in a team, you don't know what other people are doing, so it is important to know how it works. Okay. So let's see, how does that look like? So here I have a block with an if statement that has two variables, one called b1 that is defined with the let, and one called b2 that was defined with a var. Now you see, when we stop the execution inside that block, you see that there's the word block appeared in the list of scopes here, and only b1 is seen there. Okay, b2 belongs to the local context that is outside of that block. You see what I mean? So that's kind of thing that can cause a lot of confusion. All right. So just be aware of it. If you can avoid using var, it's good. But if you happen to come across it, you should be able to know how it works. All right. So that's that. That's that. And all the outer context is still accessible. Okay. Now there is an important concept here that is called the function context and the call stack. So what does that mean? What are we talking about here? Now let's say we are defining a function called add, and this function has an internal variable called counter. Now this is a function, right? So function creates a local context. So var is able to recognize it. So there is no problem with that. But we have a variable called counter equals 0, and it's supposed to add 1 every time we call and then return it. Right? So if we call it 3 times, what do you think is gonna return here? So if we try to print that, what are we gonna see? What do you think? So what are we gonna see here? The first time at least? 1. 1. Okay. What happens next time? 1. Yeah, still 1. No. Why? Because every time we have a new context, every time we try to execute the function, it creates a new context. So if we try to call it 1,000 times, it will always be 1. Okay, now let's see how does it look like here. I'm just gonna start a new So I'm gonna configure this to run in Node.js so that it would be faster. And then let's add a JavaScript. Let's say call it test here. Okay, let me just start defining the function. So we have a function. It doesn't matter how we define it. Okay, so let's call the add. Well, function. So inside the curly brackets, inside the local scope of that function, we have a variable for, it doesn't matter it's lit or var, as long as it's a function, it doesn't matter. So call it counter equals 0. All right, and then we want to add 1 to that counter, and we just want to return that counter. And let's say console.log and then add. Why is this? Okay, so we try to call it 3 times. Now let's see. Something wrong here, I'm not sure. Oh, sorry. I misspelled function. So 1 and 1 and 1. So what does that mean? And how can we trace it? How can we see that execution?